Some foods last far longer than others, and one factor in determining how long our food lasts is its moisture content, which is a measure of how much moisture there is in our food. Cookies typically have a moisture content of around 6%, while cakes are usually around 25 to 30% moisture content. This gives us some understanding into why cookies may last a little longer than our cakes do. Amino acids, such as histidine and lysine, are everywhere. Some of these amino acids are what we call essential amino acids, which are the ones that our bodies cannot synthesize by ourselves, but we must gain through the food that we consume. And a complete protein is a food such as chicken, beef, pork, or fish that contains in itself all 10 essential amino acids, meaning it's a great protein source. One thing that I was really surprised to learn this semester was that most types of tea come from the same plant, and the different tastes and flavors we get in different teas are due to different levels of oxidation of the tea leaves. Oxidation is replacing hydrogen in a compound for oxygen, and with tea this is done by leaving it out to dry in the air. For example, black tea has a much higher oxidation level than green tea does, giving them different flavors. One thing that can majorly affect how your baked goods come out is what kind of lipids you use. Cakes usually use oils, which are unsaturated fats, meaning that they have double bonds. And double bonds, as you can see, are pretty rigid. They don't move very easily, and this results in a more loosely packed chain, whereas cookies use saturated fats, or butter, that have no double bonds and can pretty freely rotate and then thus pack really tightly together, leading to a denser final product. I'm a big fan of color. Our brains perceive color when we see compounds that have high levels of conjugation. A conjugated system is a compound that has a series of adjacent p orbitals. When I saw the chemical structure of lutein in our textbook, which is the compound responsible for giving egg yolks its distinctive yellow color, I noticed that there were a lot of pi bonds, so I went ahead and counted all of the pi bonds in the conjugated system and counted roughly 20, which is a pretty medium amount of conjugation, which translates to us seeing the color yellow. And this is in contrast to albumin, the chemical structure in egg whites, which does not have conjugation, which translates to us not seeing a bright color.